This question is from May, June 2023, variant 41. A steel sphere of mass 0.29 kg is suspended in equilibrium from a vertical spring. The center of the sphere is 8.5 centimeter from the top of the spring as shown in figure 2.1. This is a free body diagram for the situation in figure 2.1. This is a sphere. There are two forces acting on the sphere. One is the tension caused by the spring, T1, and then the other one is the weight of the sphere, which is mg, 0.29 times 9.81, which will give you 2.8449 Newton. Now, since the body is in equilibrium, that means there's no resultant force acting on the sphere. That means the tension is equal in magnitude, but opposite direction to the weight. So that when add up the two forces together, you get 0. The sphere is now set in motion so that it is moving in the horizontal circle at a constant speed as shown in figure 2.2. This is a horizontal circle. Means the sphere will move along this horizontal circle. And then C is the center of this horizontal circle. To answer this question, we need to know how to resolve a force into two different components. The free body diagram for the situation in 2.2 is given by this diagram. We have a tension in the spring, which is represented by T, and then similarly, there's a weight of the sphere acting downward. These are the only two forces acting on the sphere. Now, this tension can be resolved into two components, the vertical component and the horizontal component. The vertical component is this one, which is equal to the weight of the sphere. So the vertical component will be same as T1. And then this horizontal component, which is directed towards the C, will provide the centripetal force for the sphere to move in a circle. So for this question, you need to know how to resolve force into two different components. The distance from the center of the sphere to the top of the spring is now 10.8 centimeters, as you can see from here. Explain with reference to the forces acting on the sphere why the length of the spring is greater in figure 2.2 compared to figure 2.1. This question carries 3 marks. To score the 3 marks, you must first say that the horizontal component of T causes centripetal acceleration. This one causes centripetal acceleration. The vertical component of T, which is this vertical component, balances the weight of the sphere. So the two components combine to give a greater tension. So your T is the sum of these two components to give a greater tension, and the greater tension will produce a greater extension. So this is how you get the 3 marks, 1, 2, and 3. In B, the angle between the linear axis of the spring and the vertical is 27 degrees, as you can see in this diagram. Show that the radius of the circle, this is a circle in which the sphere is moving. We want to show that this radius is 4.9 centimeters. So you can use your sign 27 degrees equals the opposite, which is R, divided by hypotenuse, which is 10.8. So your R equals to 10.8 times sine 27. This will give you 4.9 centimeters as shown. Then in part 2 of B, show that the tension in the spring is 3.2 Newton. To show this, we have to know that the vertical component is equal to the weight of the sphere. This will carry 1 mark. And then T cos theta is the vertical component equals to the weight, which is 0.29 times 9.81. This will give you T equals to 3.2 Newton. Then in part 3, the spring obeys Hooke's law. Calculate the spring constant in Newton per centimeter of the spring, which means your force must be Newton, and then your extension is in centimeter. So there are 2 marks for this question. The first mark, you have to say that the extension of the spring when T increases from 2.8449 Newton to 3.2 Newton is equals to 10.8 minus 8.5. That means when the force increases from 2.8449 Newton to 3.2 Newton, the spring extends from 8.5 centimeter to 10.8 centimeter. So the new extension is 2.3 centimeter. Then the second mark is to apply Hooke's law. Hooke's law says that F equals to K times extension. So your force is 3.2 minus 0.29 times 9.1 equals to K times 2.3. So your K equals to 0.15 Newton per centimeter. Then in part C, use the information in B to determine the centripetal acceleration of the sphere. We know that the horizontal component is equal to centripetal acceleration. So T sine theta is a horizontal component equals to M times A. A is a centripetal acceleration, which you want to calculate. So your A equals to T sine theta over M. So it'll be 3.2 sine 27 divided by 0.29, which will give you 5 meters per second squared. Then you want to calculate part 2, which carry 2 marks. You want to calculate the period T of the circular motion of the sphere. That means you must have an equation that contains the period. So the equation we use is A equals R omega squared. Since we know A already, and then your omega equals to 2 pi over T. You must use these two equations together. Then substituting your omega into your A will give you A equals to 4 pi squared R divided by T squared. So your T will be equals to 4 pi squared R over A. This will carry the second mark. Then substituting the values into the equation will give you 0.62 seconds. That means the period is 0.62 seconds.